Hello everyone. Okay, now we'll see load testing. See, guys, first point is load testing, stress testing, and performance testing comes under non-functional testing. So here we don't check the functionalities of the system as we are not validating any functionalities here. Okay, let's go deep into load testing. So what is load testing? Load testing checks how a system handles many users at one time, like in real life. So testers want to see how the system responds, find issues, and discover its user capacity. It helps find problems like slow response times, bottlenecks, and code issues and memory leaks. Companies use load testing to prevent failures, save costs, and make customers happier. Guys, see, normally when we do load testing means, see, let's say for example, assume we have developed a video conference tool like Zoom. So the capacity of our video conference tool is we can add 100 users at a time, okay, or 100 users in one session. So our tool is capable of taking 100 users in one particular session. Okay. Now in load testing, what we does, we add users from 1 to 5. This is the minimum load we apply. So how our tool is responsive when we apply minimum load. When we add 1 to 5 students into the video conferencing tool, so how our video conferencing tool is responding. Okay, now this is minimum load. Now we need to apply maximum load. What is the maximum load? Maximum load is like we will add 99 students or we will add 100 students and we'll check under heavy load conditions. This is the maximum load. Under maximum load conditions, how our tool is responding. That is how we perform the load testing. When it comes to an automotive example, guys, see, normally we use CAN protocol to communicate between the ECUs, right? So in CAN protocol, what is the bit rate of CAN protocol? In real time, we use 500 kbps, correct? Okay, guys, for load testing, this is an automotive example, okay? So we use CAN protocol. So the CAN protocol bit rate is 500 kbps. Now, guys, I need to check in 1 second if I send maximum messages onto CAN, how my CAN is responding. Like, is there any time delays or is there any errors it is raising? All these things we need to check. Let's give you more information on it. Guys, look at here. Messages sent per second, okay, equals to bit rate by number of bits in a message. Guys, you know what is bitrate? What is bitrate? 500 kbps. Now, number of bits in a message that I'll explain you. Guys, you know we have data frame. Guys, in CAN protocol, we will be able to transmit up to 8 bytes of data. Am I correct? 8 bytes of data consists of 64 bits, right? Now, see, whenever we are transmitting the message onto the CAN network, we will transmit only these data bytes or we transmit these data bytes with CAN header. What is CAN header? CAN header is start of frame, okay, arbitration field, RTR bit, okay, then DLC, right? RTR bit, DLC, identifier extension bit, then data bytes, whatever the data bytes we transmit, the 64 bits what we transmit, and CRC field, acknowledgement field, right? End of frame, IFS. We have lot many things, right? So, whenever you are transmitting any message onto the CAN network, you transmit this message along with the CAN header, correct? So, start of frame is 1 bit, arbitration field is 11 bits, RTR is 1 bit, identifier extension is 1 bit, and we have reserved bit R0, then DLC 4 bits like that. So, one data frame consists of total 112 bits along with the data field. So startup frame is 1 bit, this is 11, total 12 bits, RTR is 13, identifier extension is 14, reserved is 15. Like that, the complete CAN header along with this data bytes along with the 64 bits consists of total 112 bits. Okay, which means if you send one data frame onto the CAN, which means you are transmitting 112 bits onto the CAN network. Now guys, what we do here, if you want to check how many messages sent per second, this is the scenario what we use to perform the load testing. Okay, so now messages sent per second. Okay, what is the bit rate? Bit rate is 500 kbps, right? By how many number of bits you are transmitting? 112. Okay, now if you perform the calculation, then you will get 4464 messages, which means messages per second. In 1 second, you can transmit 4464 number of messages onto the CAN network. This is the maximum load, correct? So in 1 second, you can transmit 4464 messages over the CAN network. This is the maximum load what you can apply on CAN. Now we need to check the load testing for CAN. Now what we do, we send one message per second, okay, or we send 4 to 5 messages, okay. Then we check how CAN network is responding. Like, is there any time delays in transmitting the message? Okay. Or is there any errors our CAN is raising when we have applied minimum load? In a same way, what is the maximum number of messages you can transmit? The maximum number of messages you can transmit is 4464, right? So now, as part of load testing, now you have to apply maximum load on CAN. So now what you are doing, you are applying maximum load on CAN. So you are transmitting 4464 messages over the CAN network and you are validating under maximum load how CAN is responding. Okay. And is there any time delays in transmitting and receiving the messages? Or is CAN raising any errors under maximum load conditions? These all things we need to validate when we are doing the load testing in automotive. So the CAN load testing is one of the best example you can explain in interview for load testing, right? Now let's move to the stress testing. Yes, what is stress testing? Stress testing involves evaluating a system's behavior and the performance under extreme or beyond normal conditions to determine its robustness, stability, and breaking points. Simple. This is also same. What we do in load testing, what we are doing, we are applying minimum load and we are applying maximum load, right? And we are checking the functionality of the system or protocol, whatever it may be. Now in stress testing, what we do, no? Here we are applying 0 to 5 messages. Here applying 4464 messages. Now in stress testing, what we do, we will apply 5500 messages. We will send 5500 messages over the CAN. Now we see the same. Is there any time delays or is it raising any errors? Okay. Now this is the minimum stress what you are applying. Again, now you transmit 10,000 messages over the CAN network and check how the performance of the CAN network. What are all the time delays? Is there all the messages are getting delayed or no messages are getting transmitted? If you apply more than the maximum load to the CAN network, so how it is happening? Everything we need to validate in stress testing. Okay. So load testing is applying minimum load and maximum load. Stress testing is applying more than maximum load to the system and we are checking how our system is behaving under more than maximum load conditions, right? That is called as stress testing, right? Now let's move to the performance testing. What is performance testing? The primary goal of performance testing is to ensure that the software meets specific performance criteria and delivers a satisfactory user experience under normal and expected load conditions. Simple guys. Here what we have checked, The performance testing, in performance testing again we have to do the load testing. Okay, so apply the minimum load and apply the maximum load. Once you apply the minimum load and maximum load, how my system is responding, that you need to check. How my system is performing, is there any performance issues or not, that we need to check. Okay, and also guys, in performance testing, let's take a example of CAN network. Here, applying the maximum load, and we check the performance, like we check the stability of the CAN protocol, and we check the reliability under expected loads, right? What is the expected load? Expected load is 0 to 4464. If you apply in between 0 to 4464, if you apply this much load, then what is the stability of my CAN network, and what is the reliability under the expected message rates, right? These all things will be validated in the performance testing. Let's say guys, if you are working for an infotainment system, okay, now in infotainment system, you see, this is the HMI screen, right? So in HMI screen, you are playing a song. Now, guys, if you click on this pause button, so immediately it should get paused without any delay. Let's say, for example, you clicked on pause button and song is getting paused after taking 2 seconds or 3 seconds of time. Then performance is not good. Even though in our mobile phones, if you open the WhatsApp, what should happen? Immediately the WhatsApp should open. Now you have clicked on WhatsApp and your WhatsApp is not getting opened until 3 seconds, 4 seconds, then that is the performance issue, right? So how my system is performing. So if I click on next button, how soon I can move to the next song? Okay, so if I click on previous button, how it is responding. Let's say assume I am using Bluetooth audio. Now I want to move to the AM and FM. So if I click on AM and FM, how soon my screen is moving from Bluetooth screen to AM FM screen. Okay, all these things we need to validate in performance testing. Okay, so guys, look at here. Here we are not validating any of the functionalities of the software, so that this cannot comes under functional testing. So load testing, stress testing, and performance testing comes under non-functional testing. Okay, guys, this is the part of testing techniques. Okay, in next part, I'll be going to explain you what is smoke testing and sanity testing. Okay, yeah, see you in the next video, guys.